Okay, good morning 12th class. Today we'll do thermodynamics of adsorption. Okay, factors affecting adsorption and application of adsorption. Now in case of thermodynamics of adsorption, thermodynamics, that full chapter we have done in 11th class. ओके एंड थोड़ा बहुत अगर उसमें कुछ टर्म्स याद हों जस्ट लाइक एंथैल्पी, एंट्रोपी, गिब्स एनर्जी, ओके ऑन दैट बेसिस आई विल एक्सप्लेन यू thermodynamics of adsorption. Okay, on this basis questions are important for your board exam as well as for your competitive exam also. आता है जेई वगैरह में क्वेश्चंस आते हैं, theoretical question. Okay, now just see in case of thermodynamics of adsorption. Now first of all, adsorption of gas is spontaneous. Okay, now in case of in adsorption of gases is spontaneous. Spontaneous means delta G is equal to negative. It's a change in Gibbs energy. Now why it's written ki adsorption of gases is spontaneous? Actually just see, suppose this one is a surface. Okay, now even at this time also maybe some particles are getting adsorbed on this surface. कि सरफेस पे आके कुछ क्या लग सकता है, इस पर आके क्या हो रहा है, कुछ ना कुछ एड्जॉर्ब हो रहा है. नाउ सपोज दिस वन इज मटेरियल, हमने क्या किया, कोई एक सब्सटेंस जैसे ले लिया. नाउ दिस वन इज अ सरफेस पोर्शन. ओके, एट दिस टाइम ऑल्सो सम पार्टिकल्स, आइदर इट्स अ डस्ट पार्टिकल या कुछ भी आके इसके ऊपर क्या हो रहा है, एड्जॉर्ब हो रहा है. ओके, दिस वन इज एट द कवर या कुछ भी इसके सरफेस पे क्या होगी, ये चीज़ आके लग रही है. इट मीन्स ऑल्दो द प्रोसेस इज नॉट विजिबल, हमें दिख नहीं रहा है, लेकिन धीरे 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 इसमें क्या हो रहा है, कुछ ना कुछ पार्टिकल्स जो हो रहे हैं वो सरफेस पे क्या हो रहे हैं, एड्जॉर्ब हो रहे हैं. ओके, तो दिस शोज व्हाट, दैट वन इज द प्रोसेस इज स्पॉन्टेनियस. स्पॉन्टेनियस मीन्स कॉन्टिन्यूस, जो अपने आप से हो रहा है, हमने कुछ नहीं किया. ओके, वी हैव नॉट डन एनीथिंग बट स्टिल द प्रोसेस इज गोइंग ऑन, हो रहा है, अपने आप से हो रहा है. तो इट मीन्स दैट मीन्स वट एवर इज द प्रोसेस, दैट वन इज spontaneous. And in case of spontaneous, whenever the process is spontaneous, so in that case delta G is equal to negative. Okay, this one is one thing. Now second thing is, due to adsorption entropy decreases. Okay, when adsorption occur, okay, so what happened, that one is entropy decreases. It means the value of delta S that is equal to negative. Now just see कैसे डिक्रीज कर रहा है. इन केस ऑफ सपोज these are gaseous particles. Okay, and you know that gaseous particles are free to move because negligible force of attraction are present. And entropy, it's a degree, measure of degree of randomness. Okay, कि कितनी ज़्यादा randomness है किसी भी चीज़ के उसमें. Okay, that one is basically entropy and that is represented by S. And you know that entropy is maximum in case of gas. Okay, after that liquid, and last is solid. And in case of crystalline solid, entropy is equal to 0 because they are perfectly in ordered form, no randomness is there. Okay, now just see, previously when adsorption process not takes place, at that time simple gases are free to move, it means their entropy is high. Okay, but when adsorption process takes place, suppose this one is a surface of any solid, either it's a metal, either it's a charcoal, any solid in which adsorption occur, then gaseous particles get adsorbed on the surface. Okay, and now just see, previously particles are free to move but now the movement of particle decreases. अब क्या हो रहा है, जब वो उस पर एड्जॉर्ब हो गई है, सरफेस पे आके लग गई, तो एट दैट टाइम द मूवमेंट ऑफ पार्टिकल इज डिक्रीजेस. ओके, इट मीन्स व्हाट हैपन, दैट एंट्रोपी इज लेस. पहले के कंपैरिजन में एंट्रोपी कैसी हुई है, डिक्रीज हुई है. दैट्स वाई डेल्टा एस इज इक्वल टू नेगेटिव. ओके, नाउ जस्ट सी, ऑन दिस बेसिस we can write that one is enthalpy, either it's a positive or negative, means either the enthalpy is exothermic or endothermic in case of adsorption. Now just see, we have a simple formula, that is delta G, Gibbs energy. Formula is delta H minus T delta S. This one is a formula. Okay, now just see, instead of this you can write like this goes that side and become delta G plus T delta S. Now if you will put value, now just see, if you put a negative value for this, negative, and negative value for delta S, so this one is negative, this one also become negative, so therefore delta H is also negative. ये क्या इम्प्लाई कर रहा है, दैट वन इज डेल्टा एच इज इक्वल टू नेगेटिव. इट मीन्स इट्स एक्सोथर्मिक. whenever the value of delta H is negative, it shows it's a exothermic reaction process जो भी हो रहा है. Okay, तो in case of adsorption, it means adsorption is a exothermic process, in an exothermic process, and this one is a board question also. Okay, now just see question किस type से आएंगे. Okay, 12th class. Now just see, this one is a board question, important. Why is adsorption always exothermic? Okay, simply remember one thing, whenever this type of question is there, na, ki why this one is exothermic, this one is endothermic. If you know perfect answer, very good. At least if you don't know perfect answer, so at least write down for exothermic ki heat is released, and in case of endothermic, heat is absorbed. So now just see, in this it's an exothermic process. Why? Simple. So adsorption occur. Why? Because of attraction between adsorbate and adsorbent molecule, and in that case energy is always released. When this thing happen, adsorbate get attached with adsorbent molecule, in that case that energy is released, hence adsorption is an exothermic process. Okay, now just see, second one is adsorption of a gas on the surface of solid is generally accompanied by a decrease in entropy. Okay, still it is a spontaneous process. Why? Okay, although just see entropy is decreases, but still that one is your process is spontaneous, and you have to write answer. Okay, 12th class. Now just see, in this one your formula delta G is equal to delta H minus T delta S. Okay, now in this case, although this one is negative, but in this case that delta G is, because this reaction is, okay, delta H is also negative because adsorption process is highly exothermic. Okay, so although there is a decrease in entropy and value of S is negative, but this one is more negative, means highly exothermic in nature. That's why the value of delta G is also negative. Okay. Okay, 12th class, our next topic is factors affecting adsorption. Okay, now we have so many factors which affect adsorption, and I think you are familiar with this also because we have done chemical adsorption and physical adsorption, so उसी से मिलता जुलता है थोड़ा सा, it's almost same. Now first one is, that is nature of the gas, means we are talking about adsorbate, कि जो क्या हो रहा है, सब्सटेंस जाके एडजॉर्बेंट में एडजॉर्ब हो रहा है. ओके, नाउ इन केस ऑफ नेचर ऑफ क्या कहते हैं गैसेस, तो इट डिपेंड्स अपॉन नेचर ऑफ गैसेस. तो इन केस ऑफ दिस, those gases, those who are easily liquefiable, means whose critical temperature is high, Cp जिसका हाई होता है. ओके, तो दे आर, those who are easily liquefiable, okay, तो they get adsorbed easily, okay, as comparison to, okay, normal one. But that is in case of physical adsorption. In case of physical adsorption, because it's not specific, okay, so those gases, those who are easily liquefiable, okay, means their critical temperature is high, so okay, so they are more easily adsorbed as comparison to normal one. Okay, now just see that one is about physical adsorption. In case of chemical adsorption, you know, chemical adsorption is highly specific in nature, and gas gets adsorbed on the solid only if it forms chemical bond. अगर वो chemical bond बना रहे, then only gas form, what that one is, gas get adsorbed, otherwise not. That is in case of chemical adsorption. Physical वाले तो पता ही हैं, those who have higher critical temperature, they get adsorbed easily. Now second thing is nature of adsorbent. Okay, actually the extent of adsorption of a gas depends upon the nature of adsorbent also, उस पर भी डिपेंड करता है. नाउ फॉर एग्जाम्पल इन केस ऑफ चारकोल, यू नो चारकोल जनरली मेनी पॉइजनस गैसेज और अदर गैसेज ऑल्सो, दे कैन ईजीली एडजॉर्ब ऑन द सरफेस ऑफ चारकोल. ओके, जितनी भी गैसेज होती हैं पॉइजनस स्पेशली, तो वो ज़्यादा क्या होती हैं, चारकोल में एडजॉर्ब होती हैं, एंड दैट इज़ द रीज़न दैट चारकोल इज़ यूज्ड फॉर मेकिंग मास्क. जितने भी ये मास्क वगैरह, स्पेशल मास्क होते हैं, नॉर्मल वाले नहीं, एज आई शो यू प्रीवियसली ऑल्सो. जो स्पेशल टाइप वाले होते हैं उसमें हाईली वाले होते हैं, जिसमें चारकोल की क्वांटिटी ज़्यादा होती है, कुछ में बहुत हल्की लेयर होती है. ओके, द डिफरेंट टाइप ऑफ मास्क वी हैव. ओके, नाउ तो दैट वन इज, तो इट डिपेंड्स. तो ये कैसे होते हैं, पॉइजनस गैसेज जनरली एडजॉर्ब्ड ऑन चारकोल. ओके, तो दैट वन इज यूज्ड इन gas mask and something. But in case of normal gases, जैसे hydrogen, okay, nitrogen, oxygen, because they are not poisonous gases, okay, they are generally adsorbed on finely divided, either it's a nickel, कोबाल्ट मीन्स ट्रांजिशन एलिमेंट्स में ज़्यादा क्या होते हैं, एड्जॉर्ब होते हैं एज कंपैरिजन टू अदर वन. ओके, नाउ मोस्ट that one is regarding to nature of adsorbent. Now third one is specific area of the adsorbent. Actually in this simple thing, remember that one is larger is the surface area, larger is the greater is the process of adsorption. तुम्हें पता ही it's a surface phenomenon, तो जितना बड़ा surface होगा, more is the surface, okay, more is the adsorption, उस पर depend करता है. Okay, now तो इसी पे है कि if the surface of adsorbent is more, okay, the process is also more. Okay, large. Now next thing is that one is effect of temperature. Now in case of effect of temperature, in this one, okay, if it is chemical adsorption or physical adsorption, okay, it depends on that also. In case of physical adsorption, you know generally what happen in case of physical adsorption, that adsorption is exothermic in nature, means as we increase temperature, okay, then adsorption decreases, means inversely है. Okay, if you increase temperature तो generally adsorbate and adsorbent get shows मतलब get detached या एक दूसरे से दूर हो जाते हैं and shows process of desorption as comparison to adsorption, but that is in case of physical adsorption. Okay, and in case of chemical adsorption, you know, first it increases with temperature and after that it decreases after certain extent. ठीक है, यहाँ तक बढ़ा and after that it decreases, but that is in case of chemisorption. Okay, this one is for chemisorption, and physical adsorption it is inversely proportional. Okay, it means जो graph बनेगा वो कैसा आएगा, inversely proportional like this. Okay, then next thing we have, that one is effect of pressure, and that one is very very important because on this basis later on we will study about adsorption isotherm also. Okay. Okay, now 12th class, just see it's a effect of pressure. So in case of effect of pressure, actually at constant temperature the adsorption of a gas increases with increase in pressure, means if you increase the pressure then adsorption also increases. Okay, now just see there is one simple graph, that one is that shows variation of adsorption of nitrogen on charcoal with pressure at different temperature, means pressure is also involved and temperature is also there, and this one will show you कि if क्या कहते हैं pressure is there and that one is different temperature is given. So in this one, as we increase temperature then the if adsorption process decreases. Now just see here, this side is pressure and another one is what happened, that one is nitrogen adsorbed, कि कितनी adsorbed हुई है, that is given in centimeter cube. Now just see as we increase pressure, simple thing, तो this graph is showing what, कि that adsorption is also increasing, कि adsorption क्या हो रहा है, बढ़ रहा है, and same at the same time just see effect of temperature. इसमें temperature का क्या effect है, just see when temperature is less, ओके, तो प्रोसेस ऑफ एड्जॉर्प्शन इज मोर. देखो ग्राफ कितने ऊपर जा रखा है, जो एब्जॉर्ब्ड है एक्सटेंट ऑफ एड्जॉर्प्शन है दैट वन इज इतने ऊपर है. ओके, एंड एज टेम्परेचर द सी इंक्रीजेज, टेम्परेचर बढ़ रहा है केल्विन में. ओके, तो इन दैट केस द सी एड्जॉर्प्शन डिक्रीजेज and again it's a 273, तो adsorption okay decreases more. तो just see at lower temperature process of adsorption is high, okay, then it decreases, and if we increase pressure then temperature just see then the process of adsorption also increases. Okay, so all these are factors affecting adsorption. Okay, thank you.